Welcome. Thank you for the introduction. That's a long list of things. And I'm going to talk about yet another thing that I'm involved with shortly. But as you can see, I'm going to give you an introduction to ClojureScript, and I hope it will be adequate to your whatever knowledge of Clojure or ClojureScript you have. But before I start with that, just going back, a few of these things have already been mentioned. I'm also an organizer of Clojure Bridge Berlin, which is free programming workshops for women and non-binary people that we do in Berlin. This is also where I learned Clojure myself roughly 2 years ago. So yay for community and yay for free stuff. I also fancy myself an end-to-end encryption enthusiast, and I like to point this out because a lot of politicians and leaders of countries around the world do not seem to agree with this. And I think it is also sort of our responsibility to say, for the security and privacy of our users, we should make sure that end-to-end encryption and other kinds of encryption do not go away ever. Okay, so I thought about okay, what kind of intro can I give at a JavaScript conference when I'm going to talk about ClojureScript? And I thought, well, why not just talk about JavaScript in the beginning? Obvious. We already heard a couple of talks today when they we mentioned things oh, there's so many frameworks, and then there's this joke of you wake up and there's a new framework, and it's still true. It's it's been an ongoing joke for years, and it never gets old. And this is amazing. We have JavaScript in not just in the browser or on the server. We can make native applications. You can program apps for your TV if you want that, or for your car if you want that, and or on hardware in embedded devices. And it's just it's all JavaScript, and it's kind of amazing because it enables us to reach all these people using different platforms with just one language. But just as popular as JavaScript itself is, there's also the other joke, I would say, of how flawed JavaScript as a language is. And people over the years have tried to fix JavaScript. We saw CoffeeScript, TypeScript is now very popular with trying to fix certain aspects of the language. And while CoffeeScript and TypeScript are still very JavaScript-y, there's also languages that compile to JavaScript that take totally different approaches, like the Dart language or Elm or ClojureScript, which I will talk about today. So you might be wondering, why should I care? Because I'm pretty happy with JavaScript, and for all the good reasons that I said just a second ago. But I think if someone out there thinks that there's a reason why things should be different, and they invest all of this time to create their own programming language, which is a task that is not that easy, there's probably something that they want to tell us, and they tell us through making a new thing. I think it's worth taking a look at it and exploring and then learning something from it. And I have to say, I learned a lot about JavaScript while learning Clojure, in fact. So, ClojureScript. This is the main point for this and the entire rest of the talk. We'll have 4 chapters, actually. So just to give you an idea of when this is gonna be over, because I don't really care. This is fine. Just bear with me. Look at your phone or something. Okay. To understand ClojureScript, you first need to understand Clojure, and for that you need to understand Lisp. So we start a story with chapter 1, a functional Lisp, and with this guy, John McCarthy. As you can maybe tell from the photo, this was not last year, it was a couple of more years ago. And John McCarthy, he wrote the first Lisp as a programming language. He coined the term artificial intelligence. This was his idea to name it this, so intelligent robots or whatever. And he wrote this language that the way that he described the syntax and the ideas that he had still live on in various dialects of Lisp until today. So, for example, this is Scheme. This is how you would define a square function in Scheme. You have a define call, and then you give it a name. You call it, name it square, and then we give it an argument, and then we do something with this argument. And this is how it would look like in Common Lisp, which is another Lisp. And this is how it would look like in Emacs Lisp, which is the Emacs editor uses. And this is how Racket, yet another Lisp, would do it. And you see these look pretty similar, except for like some like parentheses jumping around. And this is like the thing, like once you like get into how this works and how it does things, it's fairly like enlightening, maybe even. But you know, they're like kind of all the same. Why is Clojure different? And yeah, let's ask this guy. This is Rich Hickey. He wrote Clojure, and he did something quite revolutionary. He introduced square brackets. So I'm not kidding. Yeah, so Clojure is a dialect of Lisp. There's another like little example to explain some of the Lisp things if this is like your first exposure to Lisp as a language. So we have things like prefix notation. So you see the plus in the beginning. This is the function that we're going to call, and everything else that follows is arguments to that function. So this is like the opposite of what you might be used to in JavaScript, where you would write 2 plus 4 plus 25 and plus 6. So we just like call the function in the beginning and then hand it everything else. Also, we don't need commas to separate the list of arguments. It's just like white space is all you need. Clojure doesn't care. Also, if you encounter a semicolon at the end of the line, this is not the end of the line, it's a comment. So yeah, as I said, Clojure doesn't care about white space, so you can like use as many new lines or tabs or whatever, and there's no need to indicate when a statement is over. Like the parentheses take care of that. And yeah, something about parentheses here. Okay, we already heard about some of the data structures earlier from Anjana, and the cool thing about Clojure, specifically in the land of Lisps, is that they are indicated by different brackets. So we have a vector, which is like an array, maybe kind of thing. It's still a bit different, which has square brackets. We have maps with curly braces. And we have lists, which are used round parentheses. Keep that in mind. It's going to be important later. And these don't just like exist in itself. You can like mix and match and like just like nest them however deep as you want. And this is really powerful because you can model data, or for example, if you like writing CSS in your JavaScript, you can also write CSS in Clojure data structures. It's really nice. And this is also useful for writing templates in Clojure or similar things that is like somehow nested and like in a semantic way. So briefly about functions, this is really important because Clojure is a functional language. And functions is really all you have to produce programs, so to say. So this is how we would define a simple greeting function. We call the function that lets us define different functions, called defn. We give it a name that we would like the function to have, greet RuhrJS. And then we have a vector that takes parameters. So we could just, for nicety, we call it greeting, and then we return the string, like a concatenated string from this greeting and RuhrJS. If we then call it, this would, like with calling RuhrJS and giving it the param of Guten Tag, it would evaluate to Guten Tag RuhrJS. So this is a simple example. If you remember from the data structures list, the data structure slide, lists are the round parentheses, and if you look closely, also functions, and basically every kind of statement, or in Clojure world they're called forms, is basically a list. And they always follow the same structure. So what I'm going to get is that functions are lists and lists are functions. And this is a type of cool thing called homoiconicity, where code is data and data is code, and you can do all kinds of things with it. But just keep this in mind if you want to Google it, because this is basically a topic in itself. As said, we return a string. Every function just automatically returns its last value. Every function always evaluates to something, which is cool, so we don't need to write explicit return statements. And yeah, so it's functional. So we have like all the cool things like higher order functions and currying and just like pass functions around or return functions and all this kind of stuff to make, fancy functional programs. Okay, so Clojure is functional, and this is kind of interesting because not all Lisps are. When I was introduced to Clojure, I was like, oh yeah, so probably all Lisps do these things, but they don't. Also, Clojure has very cool persistent immutable data structures, which we already had like an entire talk about, so I'm just gonna like say it that they rock, basically. This is also something that is fairly uncommon in the land of Lisp. So these two, the functional aspect and the persistent immutable data structures aspect, make Clojure stand out from all of the various Lisps that exist. And the homoiconicity thing that enables some of the cool dev tooling that we have, because we can treat data as code and code as data. Okay, so now that we know everything about Clojure, you might be wondering, this has nothing to do with me because I want to get applications into my browser. So let's talk about Clojure in the browser. And this is actually really nice because everything I told you is still relevant to ClojureScript, so the Clojure that runs in your browser. And you might be wondering, why? So the reason is there's different implementations of Clojure. So you can have like the same Clojure-like feel, but it runs in completely different environments. So Clojure is written in Java, and it runs on the Java virtual machine. And the cool thing about that Clojure is that it can access the entirety of the Java ecosystem, which is ginormous. So this is kind of cool. Little known fact is that there's also a thing called Clojure CLR, which is written in C# and runs or can interoperate with like .NET and like other Windowsy things, and it runs on a thing called CLR, which is the Common Language Runtime, which I've never heard before until I wrote this talk. So this is like another use case if you want to like build Windows applications, for example. You can do it in Clojure. And then there's also ClojureScript, which is JavaScript. It compiles to JavaScript, and we have access to the entire JavaScript ecosystem, be it all the browser-side frameworks or NPM modules. The cool thing about all of these is that they are all officially maintained by the Clojure project, so they are all actively like developed on, and they will not go away so quickly. The other cool thing about having different implementations is that you have community projects like Clojure, where somebody set out to implement Clojure on the Erlang VM to have perfect interoperability with Erlang, which will be some sort of like concurrency master language at some point. I don't know. Okay. So the other thing, so now we know that there's different implementations, and we know that we need some sort of compilation step to get JavaScript from our ClojureScript. And as I said, like the original Clojure is written in Java, and there's still like a lot of Java things that are necessary to get this running. The compiler that makes JavaScript out of ClojureScript is also still written in Java. So right now, if you want to do this, you probably need to at least install Java. You might not ever have to really touch it, but it's still like a dependency that you have to deal with. The good news is that there's community efforts to get this into a more JavaScript-only kind of ecosystem, so that if you want to do ClojureScript and only want to deal with JavaScript, you will soon be able to do just that, but not quite yet. Okay, chapter 3, and this is getting interesting. If you want to develop things, we need like some sort of development environment, or like something that helps us like get started and work on some things. And I think one of the most important things that it's not necessarily always part of a language, but it's always like the thing that you rely on when you develop for it is the build tooling. In JavaScript, we saw like in the ecosystem we had grunt and gulp and then webpack, and like configs like got out of hand and all these things, and there's more jokes about that. The cool thing about Clojure is that we currently have 2 build tools. There's 2. Liningen, which is the most spread out, I would say, but also there's boot, which is like gives you more configuration options, but it's also like I think harder to configure because Liningen does not really need any configuration. And the nice thing is that Liningen is also available on basically every platform. So if you're on Mac, you can install it with Homebrew, just brew install Liningen. On Windows, there's a chocolatey package called just Line, and I think every other Linux distribution just has something called Line or Liningen available for you. Also, there's on the ClojureScript website, there's a curated list of templates that both these build tools like offer you, so you can just like type a simple thing and just get started, which is what we're going to do right now. So I will use Liningen. I already have it installed via Homebrew. And I'll create a project based on a template called Reagent Frontend, which we'll talk about a bit later, and then I will give it a name. Okay. So please do ignore my Google Chrome, Google Developer Platform errors. Okay, so we're gonna do line new reagent frontend, and we're gonna call it Ruhr, I guess, and see what happens. Yes, okay, this is successful. I'm gonna cd into it and I'm gonna open it in Emacs. And so this created a bunch of things for us, just like a license, a README. If you want to see scary configuration, you can look into this, but we're not gonna actually look into this. The actual code would go into source, and then there's another thing, and then a core file, and I'm gonna make this bigger too. Where at the top we have a namespace declaration. Think of it as like a module or a scope for your program. And then we have a function called dev homepage, which will then render some HTML in the end, but we'll have it as like nested vectors. And at the bottom we have like some sort of like starting an application thing. But we'll get to that in a minute. Okay. So one really important thing that if you want to deal with Clojure, and I need to mention it, and I maybe should have mentioned it earlier, is the Reple. The Reple is your friend. The Reple is the read, evaluate, print loop. So it's an interactive shell kind of thing, where it reads an input that you give it, evaluates it, prints the result, and then you loop the whole thing. And in Clojure, but also in Elm or Scala, Reples have this like magical superpower of like you can like interact with your programs like while they're running. So it's sort of magical, and it builds a lot on the code as data homoiconicity factor, where we can basically hand it data and say we want to evaluate when we want, or also like get functions and get data out of it. And it's kind of like development cycle and work loop. That is pretty cool. As there is this, there might be only 2 build tools, but there's a whole lot more REPL implementations in Clojure, because this is what fascinates people. For the ClojureScript side of things, Figwheel is a very, like probably the most popular one, because it also includes some of like the compilation and hot reloading things, and I'm going to show you this right now. So in the folder that I created, I will call line, so with our big tool, and we start the Figwheel REPL, which this takes some time because this is heavy Java in the background and we need some startup time. But hopefully, in just a second, we'll get, the browser will open a page, and then we have both the running page in the browser and also like an interactive REPL in our terminal. Okay, so now ClojureScript has compiled. We have a little reagent app, and at the same time we have here a little prompt. I can probably make this bigger as well. I'm not sure how much the people in the back see. I'm sorry. Okay, so what is happening? For example, this page that you see here, this has been rendered to JavaScript, and this is what's running in our browser. From here, I have access to basic JavaScript browser APIs. I'm just gonna make an alert prompt and call it JavaScript. So this is how I would interact with browser APIs or whatever. The function comes first, and then the object I want to call it on, which is the window object, and then we say hi. And I just saved, and then the ClojureScript gets reevaluated, and I get a little hi prompt. And you also saw the little badge in the corner that shows like, oh yeah, there was a compilation. And the cool thing is, since we have this compilation step, if I make a mistake, the compiler can instantly tell me, oh, you made this mistake. And I do not like spend a lot of time finding like in JavaScript a missing semicolon, or like I missed like closing things. The compiler will tell me. The other cool thing is the REPL that I fired up. So this is here, I can write ClojureScript and just, well, that was a typo, sorry. And it evaluates things. You will also notice that it says cljs.user, which is the namespace which we're currently in. But the thing is, if you want to interact with our program, I can right now change into the namespace of the program that we were looking at in Emacs, and the template set it to Ruhr.core, so we're gonna do the same. Typing is hard. You see that the prompt changed to Ruhr.core, and from the Reple, I have now access to like the functions that are in this namespace. So I'm going to call home-page, and it will return, hopefully, yes, the markup that would be rendered. And this, like, the nice thing is that they are connected. So if I add another element in here, just like a p tag, and I like imagine some wave emoji. Okay, this was irrelated, I get another thing, but also like the wave appears, so this is like sort of instant. And if I call this function again in the Reple, I also get the updated version. And think about this if you're like debugging and you're like chaining function after function after function, handing input to input, and it's really cool if you can see like how the data flows, if the functions behave the way that you think they do, but then like you made a mistake maybe, and this is like an awesome tool to just like step through and see what's actually happening in your program. Okay, go back to the slides. Okay. Like the little example with the alert prompt is just like one way of how you can interact with like the JavaScript side of things from your ClojureScript code. There's like some page in projects where it's just like basically like a dictionary type where it's like, okay, you want to do access, you want to access like keys in a JavaScript object. How we do that in ClojureScript and all these kinds of things, but we don't have time to do this in depth. Yeah, I just want to mention that you can access all of these things if you want to do, in the end, have BrowserJS. You can use literally any framework and access those. If you want to do like a server-side thing, every module on NPM is yours. And not just like, you don't have just access to the JavaScript sides of things, you also have access to the Clojure community's languages, the Clojure community's packages and then libraries. If you search for CLJC, which is a project to make Clojure libraries working in both like the backend Clojure and in ClojureScript, in the ClojureScript world. So you can also like take advantage of like a community that's open, like working for a couple of years. Yeah. So back to our little app, I created a reagent front end, and reagent is a little wrapper around like just bare bones React. Why a wrapper? I could access the React API directly, but you saw that the dot something notation, and then I have to like explicitly call or like find out what the objects are that I want to call it on is a bit awkward maybe. So there's a couple of, for like I guess most of all the really popular frameworks, there is a lot of wrappers that just like make the API for ClojureScript more idiomatic and nicer to use. And this is what we use too. And for another like tiny simple example, I'm gonna open from the reagent project. They have some examples. One of them is called the simple example, which is a clock. And I'm just gonna copy this over into our little app. Okay, so it's already here. So it's a hello world. The styling is a bit off because I didn't copy the styles from the example. But what happens is this. I can go in here and like change coffee, something like this. And like as I enter the thing, you know, like data flows and I update some stuff. And if you look at the example, this is not too much code, and I hope this is somewhat understandable. In the top, we define some like things where we want to explicitly track state, and then we just like plug together like HTML and like give it some styles through Clojure data structures. And then we like the function that we have functions that simply return the generated markup in a data structure style, and then we render it and get an element by ID, which is in our markup. No magic. For the last 5 minutes, I'm just gonna like, yeah, I know, like sitting in the audience and like the person talking really wants to get you interested in the topic, but you're like, yeah, this is kind of exciting, but I don't really, show me something fun and cool. It's like, yes, I'm gonna do that. There's really cool ClojureScript projects out there. One of them is Klangmeister, which uses the web audio API under the hood to make, to live code music. So if I played this, okay, and then I can just like go and copy some of the stuff and maybe say it's a D minor. And stuff like this. And it comes with a little tutorial of like, okay, how do you composition music? And then you have like live evaluation of the ClojureScript in your browser, and that's kind of nice. The other project that I wanted to show you is made by friends of mine. It's called Maria Cloud, and this takes a bit to load, unfortunately. But what they did is, it's also like a little curriculum of like, to teach people Clojure. And they did so by like writing a little graphical library where you can also toy around the stuff. And they even also introduced some sort of like Reple-like shortcut. So if I press Command and Enter, I reevaluate things. I'm just gonna like change the number here, and hopefully nothing breaks. So this is like the diameter of the squares, and you can like toy around with this, and then just like there's a ton of stuff that you can like build some graphical applications, and it's like, things, and draw stuff, and data structures, and flowers, and all these things. I have to say that Clojure and ClojureScript are both hobby projects for me. So what I like to do in my free time is build games. Together with a coworker, we build like a simple Pokemon-style browser game that deals with street harassment. So you're a vampire and you're like fighting creeps on the street. Also, yeah, just like this was for fun, and then stuff like this. This is also possible in ClojureScript, and I think it's really cool. And I wanted to end this on like, you can do serious things with this, you can do funny things with this. The cool thing is that by like taking this different approach to JavaScript and developing in a browser, for me it was this very functional, like functions and data structures. How do you model data if all you have is literally functions and data structures? You learn, and it's not just that you learn and you like start to question things. It's like, oh, why does this framework in JavaScript does it that way? It's like, that doesn't make sense because you can also do it this way. And basically what I'm trying to get at is dare to be different, and like also like dare to like just check out what other people do, what you think, especially the things where you think this doesn't make sense, why would you ever do this? Have a look and then try to figure out why. Because this will actually teach you so much more about your own ways of programming and where you saw your own boundaries. And yeah, this will help you grow, you as a developer or as a human maybe even. And this is it. Thank you.